Another variable is the flux contained inside the tin lead or lead-free solder wire. Most of the solder alloys used for hand soldering have a core of liquid flux. Flux cored solder is like a tube that releases liquid flux. Flux has three main purposes. Once the flux is heated and activated, its primary job is to remove light oxides or contamination from the metal surfaces to be soldered. The metals to be soldered may look perfectly clean, but most metals will quickly oxidize whenever they are exposed to oxygen in the air. You might think of flux as a special kind of soap that removes oxidation or cleans metal so that it can bond properly. The second job of the flux is to prevent the freshly cleaned metals from being re-exposed to oxygen in the air in order to keep the surfaces from re-oxidizing. The liquid flux will cover or protect the freshly cleaned metal until the flux is displaced by the solder. The third job of the flux is to assist in the transfer of heat from the tip of the iron to the metals being soldered. The hand soldering operation usually happens very quickly, and it's impossible to see everything that's occurring since the parts are very small. So let's examine an animated hand soldering operation to observe how everything works. First, the tip of the iron is applied to the junction of the land and the lead to be soldered. This starts the heat flowing. Next, a heat bridge is formed by touching the solder wire to this same junction. This starts the flow of the flux and the initial melting of the solder. The flux moves away from the heat and ahead of the solder, over all of the metal surfaces. The heated flux removes oxidation or contamination from the metal surfaces. Everywhere the flux touches, it helps to heat up the metals. All of the metal surfaces need to be at the proper temperature or the solder won't bond properly. Now the solder wire is moved over to the opposite side of the land, while the solder and flux continue to melt. Liquid solder will move toward the heat. That's why you want the solder to flow from the opposite side of the heat source. Otherwise, you might not get enough solder to flow over onto the unheated side. The flux is pushed along by the solder as it performs its cleaning job. As it moves in front of the solder, it also floats away the loose contaminants. The flux and oxides will end up pooled around the edges of the land after the soldering operation is completed. Now the solder is chemically bonded or wetted to the land and lead just below the surface of the metals. Portions of the solder alloy, like tin, lead, or silver, mix with copper from the circuit board, forming a new type of metal in the area where they bond, which is called the intermetallic layer. Wetting is a term that's used to describe the adhesion of the solder to the base metal. Properly wetted solder typically feathers out to a smooth edge. Non-wetting is where the solder only wets to part of the land or the lead. The solder clumps like a ball to the top of the metal. We'll be talking a lot more about wetting later in this video, but for now, let's get back to the flux and learn more about the different types of fluxes that you may be using in various situations. The different types of fluxes used in soldering electrical connections are described in the IPC J Standard 004. The J Standard 004 separates all fluxes into one of three classes: